This video is aimed at the students who are sitting like around grade 7, 8, 9, looking for those higher grades, the last push. So I'm going to have a go at the last 3 questions on this exam. So this is the final question on it. And it's kind of, well, they're inequalities, but it's kind of like simultaneous equations, really, isn't it? If we look at that first part, the first, and can I just say, if the videos are of any use, can you please like and subscribe? All right, looking at the first inequality, I've got 4x squared minus 25 is smaller than 0. Straight away, I've got a squared number there. I've got a squared number there. So I can see that that's the difference of 2 squares. So that one's going to be 2x and that will be 2x. And then this bit here is going to be 5 and 5. I make that a plus and a minus. So that's just a dead standard difference of 2 squares thing. All smaller than 0. Right, now if I make each bracket equal to 0 to solve for the x, so either 2x minus 5 is equal to 0. So 2x is equal to, so add 5 to both sides, and then divide by 2. So my x would be equal to 5 over 2. Do the same with this one, and I've got, okay, let me change the colour. Do the same with that one, and you've got 2x plus 5 is equal to 0, which makes 2x equal to negative 5 and x equal to negative 5 over 2. If I just have a look kind of what's happening, if I think about that on a graph, I'm going to have something like that, and it will cut through at negative 25, so it's a quadratic. Now that bit and that bit, those points on the x-axis, that's where the minus 5 over 2 and the positive 5 over 2 are. Now, because this is under 0, it's smaller than 0, I'm looking at that part of the graph there. So that means that I can now say, I'll just go up and put this answer there. I can now say, now, all you've got to do is write it like that. Always start it like that, x, the inequality, and notice it's pointing to the left, minus 5 over 2, positive 5 over 2, and that's that bit there done. Right, let's section that off, and I'll have a go at the other side, and then we'll put it together. So I'll go back into white again, because it shows up good. All right then, so this one here, so I've got 12 minus 5x minus 3x squared is greater than 0. Right, few things standing out about that. What you want is the inequality sign to be facing that way. And notice that there's a negative as well on the 3x squared there. So you want to sort of change that before you start. So think of it like this. Let's go into that colour. Think of it like this. If I put that minus 3x squared over to that side, right, it'd go positive, wouldn't it? So let's have the inequality sign. So I'm doing it the same way round as that, right? So I've got the 3x squared positive. If I put this negative 5x over, that goes positive. I'm going to stick that 12 over as well, which will go negative. And I can put the 0 over this side. And it doesn't matter, does it? Because, if you add or take anything, with 0, it's not adding or taking it, losing any value. So I can what I've kind of got now, see here where it was pointing at the 0 before, wasn't it? It was greater than. Now it's pointing at the 3x squared, which is what I want. So just writing that out kind of in a format that we like is I can say 3x squared plus 5x minus 12 is all smaller than 0 now. So the 0 has kind of flipped round with it. And what you've done really is times through by minus 1. Right, now I'm going to think about factorising this inequality now. Now, because the 3 is prime, it's going to start like that, isn't it? Smaller than 0. Then you've got to think about the factors of this minus 12. So I could have like 1 times 12, 2 times 6, or 3 times 4. So it's got to be a combination of one of them, what's going in these spaces here. Right now, there's a little bit of fiddling around with it. Like when you think, say I looked at that 1 times 12 there. If I put 12 there in this second bracket, 3 lots of 12 is going to be 36x. You know, you can see it's going sort of too high. So you can do a little bit of fiddling around with it. And it's got to be a combination of one of them. And one's got to be positive and one's got to be negative to get this negative on the 12 here. Anyway, going on to factorise that. It's 3x minus 4, and the other bracket is x plus 3. Now, if I look at them and kind of like solve for the x here, so make it equal to 0. So I'm doing this bracket here first. So that means that 3x would be equal to 4. X would be equal to 4 over 3. Right, and this one here, so x plus 3 is equal to 0. So x would be equal to negative 3. Right, now let's see what's happening with this. So I'm just going to take a bit of, make a bit of space here with this. And we just have a little look at what's happening with the graph. So what it would look like if I had that plotted, it would kind of be like this, wouldn't it? You know, where we would have, okay, so it'd be quite steep. Got to cut then, isn't it, at negative 12? So it's got to be something like that. Negative 12 will be here. And we've got this C will be where the minus 3 would be. And there would be where the 4 over 3 would be. So it's all that part of the graph, all under the 0. Yeah. Okay, it's all them values here. What would work and make that equation valid, true, smaller than 0. All right then, so just the last bit now. So can get that into into an inequality. And what I'm doing is literally just putting it at each end. Okay, so this one, the second one, comes out at that. So do the same, x. Yeah, the inequality sign each side of it pointed to the left. And I've got minus 3 on that side there. Oops, it's meant to be a 3. And 4 over 3 on this side. Right, last part now for the final mark. So what is the possible set of values, you know, putting them together where they're both got to suit, be true to that inequality. So it's got to be the end of that one and the top of the other one. So it's the lowest number in that one. So don't forget x and x, point them to the left. Not x and x and the inequality each side. go to the bottom of the first one, minus 5 over 2, and go to the top of the other one, which is 4 over 3. And that's it, done. Question 23 on this paper, it's a third question. I would say that that was a difficult question, this one. So showing the form, now this is something that you see, so a root 3 plus b over c. So it's a fraction takeaway, subtraction with thirds. Now straight away with that being c on the bottom, and it says there that c is an integer. So when I look at these, they've got these thirds on the bottom. So straight away, it's got to be one of them where you've got to rationalise that. So let's have a look at that first part. So 3 root 3 over 4 take root 3. Now it takes loads of space, this type of question. And you know, you've got to go slow in steps. So to rationalise that, I'm going to times it by whatever is on the bottom and change the sign. Okay, so 4 plus root 3. And what that does is it's a sneaky way of timesing by 1. Anything over itself is 1. So you're not going to like change the value of that fraction. You're just going to show it in another way. But it's a very good way of getting rid of the thirds on the bottom. So that's going to take that business out. So if I times this out, on the top I've got 4 3s are 12. Right, so I've got 12 root 3. And then times the other bit. Now root 3 times root 3 removes the root. So that just becomes 3 times 3. So it's 12 root 3 plus 9 on the top. Now on the bottom, so think about sort of timesing this out like you would do a quadratic if it was x's there. So I've got 4 4s 16. Now this is why we use this, because if you look, if I say 4 times positive root 3 would give me 4 root 3. Take away 4 times negative root 3. So it takes that middle term and takes that third part away. Then I can just say root 3 times by root 3 is 3, and it's negative, positive, negative. So negative 3. So I might as well just get rid of that and say we've got 16, take away 3. So we've got 13 on the bottom. So we've got that first one rationalised now. So the second one isn't too hard to rationalise. I think that could be like maybe comes in about grade 6, that bit. So I'm going to do the same, just times it by whatever's on the bottom. So root 3 over root 3. And that's going to give me 2 root 3 over 3. Right, so that's, they're the two fractions that I'm dealing with. If I like section that off and then let's put it together so I can see what I'm working with. Right, so I've got, my first fraction is 12 root 3 plus 9 all over 13. Take away 2 root 3 over 3. Right, so that's what I'm aiming at. Now when you think, if you subtract any fraction, say I've got a half, take away a third, say, you know, what I do is I times the bottom to get a common denominator. So we'll do that on this one as well. So I know 13 times 3. So it's going to be like 39, isn't it? On the bottoms. That's the common denominator. Then to get like the top number at times there, you know, see if the top's gone up. So I'm going to do that with this one. So it's have 3 12s. So I've got 36 root 3 plus 3 9s 27. Take away And then it's the opposite, isn't it? It goes that way. So 2 13s, so 26 root 3. That's what my second one is. Right, and I've got it now, because once I've got the 39 on the bottom, I can put it together. So I've got 36 root 3, take away 26 root 3. So I've got 10 root 3, plus that 27, all over 39. Okay, and there's nothing further I can cancel, but I've got it in that format now. So A was equal to 10, B was equal to 27, and C was equal to 39.